commercially available acrylic resins which contain either acrylic or metacrylic esters. There are three different types of paint brand used in our experiment, which are Nippon, Deluxe, and Characterization. And the equipment used for our experiment is the DSC and FTIR.
The Acrylic and alkyd are likely used as binders in paints. The difference between acrylic and alkyd are alkyd paint is more toxic for the environment than water-based acrylic paint. It is due to the presence of volatile organic compound which is detrimental to health and lead to environmental pollution to water sources. Moreover, the alkyd paint is expensive and it takes longer time to dry and will extend the time between coating of the primer and top coat. The example of alkyd paint are aliphatic hydrocarbon, ethyl acetate, glycol ether, and acetone. Acrylic paint comprises of three types, which is pure acrylic, styrene acrylic, and polyvinyl acrylic. Pure acrylic contains monomer based on ester of acrylic acid, while styrene acrylic is formed out of copolymerization between styrene and different ester of acrylic acid. The lastly is polyvinyl acrylic. The base emulsion is formed from copolymerization between vinyl acetate and acrylic or vinyl acetate and ethylene. Also, a thermopolymerization of vinyl acetate, ethylene, and vinyl chloride. For the limitation of study, the characterization or using the DSC and FTIR is yet to be complemented using laser diffraction analysis and swelling. It is for the further understanding of surface microstructure of it. Laser diffraction can be used to detect the level of crystallinity, while swelling test can be used to quantitatively determine the cross-linkacity. DMA, dynamic mechanical analysis, can be used to test the mechanical properties of the paint against wear and tear.
Okay, so for the materials that we use is DSC and FTIR equipment, and we use a related apparatus, and our sample is Nippon, G2&G, and Deluxe sample. So for the preparation of the sample, we casted 3 samples of paint on different gas light, and we dried them under the sun for 24 hours. Then we weighed the sample and put them on crucible, and we cleaned the crucible with a lid. And for the calibration of the DSC instrument, we use indium first for the reference, and the temperature we use is until 280 degrees C, and we get the integral and normalized value from the software. And for sample analysis, first we replace the indium with our first sample paint, that is Nippon, and the temperature that we use is in range 30 degrees C until 600 degrees C. And the first thermal cycle was recorded. We get the heating curve, and the same step we use for the other sample paint, which is Deluxe and G2&G. And so for qualitative analysis of paint using FTIR, we first done the background check on the FTIR spectrum, and then we use the first sample paint with its Nippon and we place the paint on the crystal, and we ensure that it make a good contact. And then the sample paint for liquid and solid were measured. From the result obtained, we record it, and the detector we clean with wet tissue with ethanol. After that, we repeat the same steps for Deluxe and G2&G sample paint.
Present about the result parts. First, we have done for the thermal stability, which we have received the thermogram from the DSC. So you can see the curve, which is there's a peak over there. So we have interpret the peak as for the temperature for the TG, which is a glass transition, and also the melting point. So there's another one, which is we have used the result that we obtained, and we interpret it using which is the enthalpy difference, and also the mass, and also the calorimetric constant, and also the temperature difference to obtain for it to see for the difference and also the compare between the 3 samples. So now I'm going to present about the another part, which is we are using the FTIR to look for the bond between the inside of the sample we have. So this is in the screen, which shows that the wavelength for the different liquid paints. So we can see that there's different peaks over there, which represent the three colors, which is the blue color for Deluxe, and orange color for the Jordan, and the gray color for the Nippon. Here is another liquid paint, it's solid paint for the FTIR result. So there's a difference you can see between for the liquid paint and also the solid paint. So there's a difference. So here I'm going to show how we interpret for the result. Okay, so you can see there's a table. So there's a transmission wavelength. So we have determined the wavelength according to the reference. Is like for the 2800 and until the 2900, there's a wavelength which in the appearance of the medium, which shows the CH stretching. This represents for the alkane. So this means that in the sample there's an alkane bond present.
Next, for the discussion part of the SC, this is the figure that we get from the instrument, which is for Jordan paint, Nippon and Deluxe. And we use reference is indium. It is a chemically and mechanically stable metal. Next, the reference temperature for our sample is acrylic emulsion is 345 degrees Celsius. And next, we use nitrogen gas as purge gas because it can prevent the sample to be contaminated. And the mass of the sample, as you can see in the figure, for Nippon, for Jordan is 1.5 gram, for Nippon 3.2 gram, and for Deluxe is 3.9 gram. Grading temperature, which is we get from the first peak, which is the glass transition temperature. For Jordan brand, we get 381.63 degrees Celsius. For Nippon, 389.37 degrees Celsius, and for Deluxe, we get 376.44 degrees Celsius. While for the burning temperature that we get from the at the last peak on the previous graph, for the burning temperature for Jordan is 520.27 degrees Celsius, and for Deluxe is 528.41 degrees Celsius. And the colorimetric constant, which is for Jordan is negative 0.9999, and for Nippon 1.2626, and lastly for Deluxe is 0.999, same as Jordan.
So to explain why there's a difference in glass transition temperature, first we have to determine what are the monomers that present in the acrylic emulsions. So as you can see in these slides, there are two functional monomers that can be shown here, that which is hydroxyl groups OH and carboxylic groups, which is COOH. And these two groups will bind together to form esters, which is a form of cross-linkage bonds. And then in the middle one is a type of monomers that will form a self-cross-linkage. And then in industrial usage, basically two types of monomers are used. It is either acrylics or methacrylates. So these are the functional monomers that exist in the monomers that is ideally joined together with acrylates or methacrylates. So as you can see, we also have the formation of amides, which is formed from the amines and carboxylic acids. And then as you can see, ester is formed by the interaction between carboxylic acid and alcohol. So the effect of chemical natures and the effect of cyclic nature will affect the cross-link density and also the cure rates. So as for chemical natures, ether is a very stable functional group, so it won't react to form any side linkage, which is why alkane is a better one for cross-linkage because it has a higher cross-link density. As for linear form of monomer, it is better as it is increase the probability of its reach towards the side monomers of another functional groups. So in the range of 3,300 and to 3,500, we have water, which is the solvents of acrylic, which is a water-based paint. And then it shows that water is present as the solvents of these things. And then also from 2,800 to 2,900, we will have the CH stretching, which shows that aliphatic back bond chain is the highest in Nippon paint, followed by Jordan's and Deluxe. So the higher the chain, the longer the chain is, so the higher the probability to form cross linkage. So this this slide explains about a lot of functional monomers in the liquid samples. So first of all, we will have OH stretching, which is the alcohol intermolecularly bonded to the functional monomers, and we will have a nippon pin that's the highest. So the OH group will actually cross-link with carboxylic acid to form ester, and then increase the cross-link densities. Also, we have CH, which is shown as aromatic compounds. So this shows that the type of paint we use in these experiments, 3 of them are styrene alkalis. So in this slide, we can see that there's a C double bonds, which is shown as alkene. So we can see that it is a mono-substituted CC double bond, and then it proves that acrylic is used instead of methacrylate, because methacrylate is a CC double bond, but with di-substituted nature. So also we have CN, which is amine groups, and then Jotun in this case has higher amine group than nippon paint, and then so which is why Jotun obtain the highest TG from these bonds itself, which is why the TG between nippon and Jotuns are almost the same. So the formation of secondary amine out of these paints with carboxylic can form amine. So in the range of 1,638 to 1,648, we can see that alkene is present, and then the presence of alkene is mono-substituted, which proves that acrylate is used instead of methacrylate. So acrylic, although it has a lower TG than methacrylate, but it is cheaper as well. So because we know that methacrylate is CC double bond di-substituted, so there's no di-substituted CC double bond, so methacrylate is proved to be non-present in these samples. Also we have CN, which is amine group, so the formation of amine can be formed between amine and carboxylic acids through cross-linkage, and then in this sense, the Jotun has the highest, followed by nippon paint. So Jotun obtains amide group higher than nippon paint, which is why both of Jotuns and nippon TGs are almost the same. So in the range of 3,584 to 3,700, we have OH stretchings, which is alcohol, and then it is only shown in Jotun sample, and then this shows that there's a little errors that happens during the drying process, which is what there's moisture that is not fully dried, and also we will have NH group, which is a secondary amine, and then this is also a cross-link bond. So the formation of ester can be proved in the transmission wavelength of 1,735 to 1,750. And then this proves that polymerization has actually happens in the drying process. So in the range of 1,000 to 1,400, only nippon paint has this bond, which is CF stretching, and then CF is actually contributing to fluorocopolymers, and CF bond is actually a very strong bond. It's one of the strongest bond in organic chemistry, and then it has the bond energy of 185 per moles of bonds, and then this bonds is contributing to the non-stick property, thermal resistance, and water repellent property. So which is why nippon paint is amongst the most special one in all of these 3 paints.
So in conclusion, for the DCS analysis, we have obtained the TG and the TM for each brand. So the TG and the TM values for brand Jotun is 381.63 Celsius and 521.27 Celsius respectively, while for brand Deluxe is 376.44 Celsius and 528.41 Celsius. Finally, for the paint brand Nippon, the values of the TG were only obtained, and this value is 389.37 Celsius. And for the FTIR analysis, it was determined that the brand Nippon had the best thermal resistance, and that's because of the fluorocopolymer shown in the CF bond, while they had they had a longer alphabetic backbone and highest OH and COH. And for the second best thermal analysis is for the Jotun brand, and that's because they had a distinctive highest NH2 functional group, leaving that the Deluxe is the lowest.
Next is the recommendation for the thermal characterization using the DSC. First one is the weighing session. Okay, we use the analysis is free from air for an accurate result, because the results of heating is very reliable on the weight of the sample. The second one is the method of sample handling. The cap must be sealed properly to ensure there is no entrance of other heat source which can affect the results. The second one, we need to use new crucible for every repetition, and the sample must be handled using forceps instead of hand to prevent any contamination. And the last one is the method of sample preparing. We need to cut and fit the sample inside the crucible and use the cap properly to ensure the process of heating is done completely. Okay, next one is the FTIR scanning method of sample running. The first one, the cap must be put properly to ensure there is no entrance of light which can affect the results. The glass used to place the sample must be cleaned regularly using ethanol, and the sample must be handled using forceps instead of hand to prevent any contamination. And the last one is method of sample preparation. We need to cover the sample container using plastic instead of aluminium to ensure the absorbance of UV light, which will help in the curing and drying process.